Hello, everybody. I'm meteorologist Jeremy Wheeler, and it's time for another edition of WAVY Science Lab. I'll be your host today, meteorologist Jeremy Wheeler. And so we've got a good topic for you. We're going to be talking about fire and all kinds of things about fire. People get really excited. It's a really active topic. And we've got all these songs that we're going to play for you off the top. We have, what's that? What's that? Okay, well, I guess we're not going to do that because of the budget. And okay, well, that's fine. Well, we got some great tools we're going to use. We got this flamethrower over here. No flamethrower. Okay. Well, we've got a nice candle lighter. That got cut too? Well, anyway, no, I'm just kidding. We're going to have a great show for you, as Jon Stewart says in the beginning of his show. We got a great show for you. So no, we're going to have some fun. I was just having a little fun with you there. But there's some cool songs that I think of just off the top of my head. Pat Benatar, Fire Away. We got Light My Fire, The Doors, the Blue Stones, Be My Fire. Just all kinds of cool stuff we can think of there. So anyway, let's get into it and talk about the actual topic and talk about some science things for once. So the science of fire. It's hot, right? So fires, we had a fire here outside of our studio not that long ago. And so I got to record it, and I think this might have been recorded off my phone or the actual tower cam itself. Well, it was a tower cam, but through our equipment. And you can see the fire truck there, just putting the water on top of the fire. It was a business that had started on fire, and you can see the fire truck there, and it's all kinds of craziness, just scary stuff. I mean, you see the smoke rising. So where there's smoke, there's fire, right? Isn't that the saying? So fire, about 1 million years ago. And I thought maybe that, but I saw a couple sources say, about 1 million years ago that ancient humans discovered it about that time, changed humanity. Cooking, warmth, light, it was introduced. I mean, it really did change humanity. I mean, it was a great tool, especially for cooking, but, to stay warm. They'd take the flames in the caves and try and stay warm in there in the wintertime. And light, at nighttime. And then also, I mean, used as a weapon. In some cases, maybe to keep off predators, maybe to fight off other humans, used to clear land. Eventually, once they got into farming, they could use that, and then burn waste, which is gross, but it is done. So fire equals combustion, and so it's a chemical process. Combustion, the chemical process when a substance reacts rapidly with oxygen and gives off heat. Heat, fuel, and oxygen are the three things that go into this. And so, the fuel is a substance like paper, grass, trees, a candle wick, gas, fuel, some kind of fuel, etc. It could be a solid, liquid, or a gas, especially when it comes to rockets, things like that. So it can be a liquid. So fuel plus oxygen equals waste plus energy, kind of a simple equation there. But we're going to get into some fancier ones here in a little bit. The fuel becomes oxidized. So whatever that fuel is, whatever the chemical compound is there, it gets an O. It gets oxidized. So it's an oxidation process. Needs some energy to kick off the reaction, though. It can't go by itself. You can't just have a flame just poof. Well, unless you do magic. But even then, I think it takes a little something. So and once started, then it can self-sustain. So a typical fuel is a hydrocarbon. And these are elements of hydrogen, carbon together, so hydrocarbon. And so the element-wise, oops, let me take you back. For instance, gasoline, methane, propane, butane, all the anes in there, they're used as fuel. So methane, 1 carbon, 4 hydrogen atoms, and then you add, that's the chemical makeup, plus 2 oxygen, 2 O2, yields a carbon dioxide plus water plus energy. So you get the reactants on the left, the products on the right. And that's combustion in that case. So natural fuels, you've got wood, which are basically, wood is carbon, hydrogen, and oxygen atoms together. And it's just a different, orientation of them, different, combination of those. Grass, leaves, trees, they're all, they're hydrocarbons. And so you can get natural ignition, lightning that causes a lot of fires out west, lava in some cases, maybe Hawaii, and then of course there's humans as well, and so lighters, cigarettes, power line sparks, problem out west, especially, but even here in the east, sometimes we'll get a problem from something like this. We have had wildfires before. We've had some brush fires, and then we've had we had a bog fire, I think, a couple times in North Carolina, peat bog. When that starts on fire, it's a lot of it's underground. It just smolders. It can stay on for a long time. It takes a lot of water to really drown it. And so that we've had that happen. That was a few years ago, I think, in North Carolina when we had that happen. Anyway, that's also some fuel for those fires. So if gasoline burns in air, there can be some pollutants. You can get, air is 78% nitrogen, 21% oxygen. You get that nitrous oxides to be produced. And that's one of the pollutants that can happen, carbon dioxide, of course, but that's another one that's a no bueno. So this is really interesting to me. Some things I didn't know about fire, and now you will hopefully know. I looked up the ignition temperature of fuels. So charcoal, 660 degrees Fahrenheit, which it seems very hot, but it does take a lot to get that charcoal going, doesn't it? 349 degrees Celsius. So gasoline is 536 degrees Fahrenheit, 280 degrees Celsius. So it's kind of the trigger point. You have to get that temperature going up to that for the reaction to get going, and then it keeps going. As long as you have all the fuel and the oxygen going into it still. Once you're out of fuel, then it stops. Paper, very interesting, 451 degrees Fahrenheit, 233 degrees Celsius, and then wood, and this is kind of an average for the wood, 572 degrees Fahrenheit. Oak was 900, and there were some that were less than that. And we're going to go a little bit into that, why oak is just not your average. It's on the high end there. Jet fuel, 410 degrees Fahrenheit, pretty cool. And a rifle powder, 550 degrees Fahrenheit. So, yeah, and you can see the site right there. You can go check it out yourself. And, I never thought about it that much. I a little bit, but just so cool to see how they relate to each other, too, just numerically, and kind of combine the differences there. So there you go, ignition temperature of fuels. All right, so you got firewood. It's best to age it for a few months as, it gets the moisture out and the fibers break down a little bit. And then harder woods burn longer. And we'll go into that coming up right after the break because we're running out of time here. So we'll have that coming up after the break. Stay with us. All right, we are back, and we're talking about fire today. And we are talking about all kinds of things about fire, kind of, how it forms, the chemical reactions so far. And we talked a little bit about firewood. That's what we left off with. So let's get back to that. So, it's best to age it for a couple to a few months. Gets that moisture out. As long as you keep it covered. I've got, a firewood pit and, keeps it covered. The fibers break. The harder woods burn longer because they're more dense, which makes sense, right? You get less oxygen to get in there. You need oxygen. And so the softer woods are less dense and they burn a little faster. But if you want, you get a piece of oak, you age it for a while and then put it in a fireplace or a fire pit and it will take a long time, but it takes a while to get it going too. That's the other trade-off of that. You need a lot of kindling and a lot of other stuff to get that going. So wildfires are unplanned fires that happen in forests, wetlands, and grasslands. And so we talk about this quite a bit now. We'll kind of focus on that. So these wildfires can happen just about any time of year, but there are seasons when they're more common. Since the 1970s, Western wildfire season has gone from 5 to 7 months. And so, the average burn time of individual fires has grown from 6 days in the 1970s and 80s to 52 days between 2003 and 2012. Wow, that's a scary number. I mean, and we've seen it in the news so many times, especially in the 2000s, all these huge fires that last so long. And so, there have been. So increased wildfires, due to rising temperatures, reduced winter snowpack, and then less summer rainfall as well. And, these are some factors. You get global warming. And so, this has part of it. It's not all of it though. I mean, there's a lot of other factors in here. Humans are using a lot of water, and so some of those reservoirs are getting used up. Water usage, things like that. So you get faster evaporation and you get more droughts. We've had a lot of droughts over the years. So wildfire spread kind of depends on the terrain, the fuel, the dryness that's out there. The flames burn faster uphill compared to flatland outside of the weather, because the weather can drive it, of course. You can drive it uphill, drive it downhill. But, if you get super strong winds, but without much wind, that's the case that it makes sense that it burns faster uphill. And then the heat from the flames can dry out the fuels ahead of the fire, and the flames and embers can leap, especially if there is wind. And so it can then get that fire going. So here's just a kind of a representation of that fire. You get one spark, it gets going, and then the flames start increasing, and then the wind blows it upstream, and then it heats up the fuels ahead of it, and then they'll start on fire once they get to that certain temperature as well. Oh, I could look at this all day, right? So wildfires, let's get into it a little more. Why wildfires happen. So you've got dry vegetation, low humidity, and you need that wind usually. If you don't have much wind, the fire, it might travel, but when you get the wind, then that's when it really spreads. And firefighters, they got to fight so hard against it, especially out west. So you need heat, fuel, and oxygen for a fire to get going. So you get the heat source, and we mentioned, it could be natural lightning, it could be from human sparks from maybe a power line, something like that. And then you've got the fuel there: brush, prairie grass, trees, excellent fuels, fire. So we just had a lightning strike, and now the flame gets going and travels and gets going up that hill, and then it just spreads, and it can get out of control very quickly in some cases when you've got the right conditions, and that's no good. So during wildfires, prepare to evacuate if we ever had one. We're in a most of you watching probably are in the metro area. And so, it's not like we're surrounded by a lot of forest, which actually, now that I think about it, there are sections of the metro that are, but there's some rural areas that are just all foresty. And I can think of several. And so, we could potentially get a wildfire. It's possible. So you listen to emergency channels and know the status of fire. I'm sure there'd be an alert on your phones. Put emergency supplies and must-haves in your car so you can evacuate quickly. If let's say there's a big wildfire going on and it could spread maybe close to your home, then maybe you would do that. And then to avoid burning leaves, tossing the cigarette butts out, try and put those out in a safe place. Having bonfires, burning debris, maybe, try and avoid that. At certain times of the day, there's some cities that say you can't burn outside during the daytime, outside of a fire pit, which is closed off, but like just a brush fire. We used to do that all the time when I was up in Illinois. We used to have, my mom used to burn leaves all the time, and it was just very common. I was, Illinois, summer, and just about any time of year. But around here, there's certain laws that you can't do that, especially if we have a drier bunch of months. Then there might be some state laws, what have you, city ordinances, things like that. So make sure you check and see if you're going to try and do that. But some do it around here. I mean, it is done. I've seen it, but I don't do it except outside of a fire pit. I do have that. All right, so and then grilling. Don't grill over grassy areas. You want to try and do it on concrete, and then parking vehicles in tall grass, because the bottom of your vehicle gets really hot, and if you have tall grass, that can start a fire. Some people might not think about that part of it. So this is from National Park Service, and this is out west, of course, but yeah, this is the fire burning up a mountain. It looks like, or burning on top of a mountain. This looks like a brush fire, grassland fire. Yeah. And, look at that. The grass looks so dry. So you could just tell that is some really good fuel for that fire line right there. And, and then this is some other fires. Look at it. It looks like there's multiples out there in some places. That's interesting. And they do controlled burns. We're going to talk more about firefighters, but they do controlled burns. So maybe that's what some of that is. It's hard to tell. Or maybe there was a fire in the distance and they put some of it out. It's hard to tell. Very cool to see from the air, though. There was a forest fire up in Gloucester years ago, and I went up in Chopper 10, and I got to see them working on the fire. John Massey was the pilot at the time. This years ago, and very cool to see below me. The helicopters were picking up the water and putting on the fires. That was in Gloucester again. That was a long time ago. And so anyway, there's a little closer view. They had the fire movie with Matthew McConaughey that was really good. I can't remember. And there was that was pretty good recently. I think it was on Apple. And then there was another one years ago, Home of the Brave, I believe, and Josh Brolin, and that was the one about the firefighters out west. So it's one thing to see it, when it's in your home and on TV, but then to be in it and surrounded by it would just be so unnerving. I can only imagine, that would be really tough. So, and the firefighters, we're gonna talk more about that coming up after the break. But yeah, the firefighters, the U.S. Forest Service has about 10,000 plus firefighters, highly trained, and the hand crews, 20-person team. They construct fire lines. We'll have more coming up after the break, though. We're gonna take a break right here. All right, stay with us. All right, we are back, and we are talking about fires, and we've covered a lot of ground. Now we're talking about firefighters. So the U.S. Forest Service, again, just to recap, has 10,000 plus firefighters, highly trained, and there's different kinds. Hand crews, 20-person team, construct fire lines. Hot shots, we've heard about them, work on the most challenging areas in the fires. And then you have engine crews, team of 2 to 10, work with the specialized engines. So this is from the USDA, some pictures of firefighters out there working on the fire lines. And thank you very much for all the firefighters. These are the ones out west usually, but hey, local firefighters as well. Just thank you so much for all you do. Some of them are volunteer firefighters. Some of them work, but they still go through a lot. And, thank you very much. Anyway, this is looks like they're working with a fire engine right there. I don't know, maybe a brush rig, something like that, from my days of reading books to my kids. So anyway, life after wildfires, right? So fire clears the land, breaks down organic matter into soil and nutrients, and puts nitrogen in the soil. And there's less competition, more sunlight. So seedlings actually can grow rapidly from this. And some have adapted to where they actually like fires. I think the seedlings actually sprout after those fires trigger them or something like that. It's been a long time that I heard that, but yeah, so things do grow right after that. So some of the worst wildfires history, Texas, 2004, there's a fire in February that burned 1.1 million acres, largest in Texas history. There's Maui, of course, that happened recently. Rapid spreading fire, 100 plus lives lost, very sad. And then the Dixie Fire, California, 2021, heat wave caused mainly 460,000 acre fire. Over 14,000 structures burned. And then the Bay Area, California, 2020, 1 million acres burned, 35 people killed, fortunately. Camp Fire the Camp Fire in California, 2018. That one was a big, famous one. Bad rapid fire burned 150,000 plus acres, killed 85 people. There's one, was it last year? Also in California. And then there's just many others before the 2010s. So then there's the Great Chicago Fire, 1871. You may or may not have heard about it. Very warm and dry conditions beforehand. Fire broke out on the 8th, became a huge fire. 300 deaths. Wow, that's bad alone. But 100,000 homeless, and it erased 2,100 acres of the city. And then about the same time, Peshtigo, Wisconsin, there was a fire. I think it was about the exact same time, almost. 1,000 plus people killed in that one. And so these fires, back then they didn't have the same fire departments, fire safety, things like that, like we have today. So I thought this was very interesting. The fire colors depends on the temperature. So barely visible, you got a dark red, 977 degrees, and these are in Fahrenheit. I had to convert them. You get that kind of medium flame there, kind of the top right one, 1,800 degrees. And then once you start getting that, the brighter orange, 2,300 degrees Fahrenheit, and then white hot, 2,700 degrees Fahrenheit. So yeah, that's it. You can actually tell how hot the fire is from that. And then you got the blue flames from let's say propane. Let's say the other ones were wood burning. So these are propane. If it burns completely, then it's blue. Maybe not 100%, but 90 9%, something like that. Not as much carbon monoxide is released then, not as much. And then it burns about, wow, that's interesting, 3,578 degrees Fahrenheit. I mean, I've gotten that. It's weird though, because these temperatures, that must be right at the flame. Because when I get my fireplace, I mean, it's not like burning my, me, right? Just that being that close within a couple of feet. So must be it. But you can get pollutants from it. Nitrous oxides can be produced, carbon, which is soot, and other chemicals, benzene, ozone, things like that, especially when it doesn't burn completely, or if you got some special chemicals, certain things start on fire, they can release those. So then you got candle flames. The wick, not John, is fibrous. The paraffin wax, which is the hydrocarbon and petroleum byproduct, is in there in that candle. So the flame burns the wax, and more is pulled through the wick, right? It's pulled up, and then more burns from that. It seeps up. So the top of the wick burns as well, but slowly, very slowly, right, over time. And then the wax is solid at room temperature, which we're familiar with. Pretty neat. So there's me lighting a candle at home, and just a simple candle. It smelled great. I think it was maybe one of the maple bacon ones we have. I don't remember. But yeah, so I had a lighter, and so you got the ignition for that, and then you use the lighter on the candle flame, and you got to get that temperature going up to a certain point to trigger the reaction. And so there you go, the candle gets lit. And then it's you got the three. I just lit the one just for this demonstration, but of course you light all three of them. And then this is a fireplace that we have, and so this one you just hit the trigger, the button. It is I believe propane. It's natural gas. And you got the blue flame and the orange, and they're designed to have both, so you can kind of get the aesthetics out of it. But if it's too much orange, then that means that you might have not enough oxygen in it. And so let me start that again. And so you may have to get it checked out. There's companies that check out fireplaces. We used one a while back and had it cleaned a little bit. I clean the fireplace myself about once a year. To remove some of the soot, but then you get it professionally worked once in a while as well, just to be extra safe. So that's the fireplace, and they're great to have, especially the those, because they get the wooden ones. It's a lot of cleanup, so I've had those before. But anyway, fire safety: never leave a fire unattended. Candles, campfires, things like that. Especially use a vent when cooking with gas, and have a plan in case you have a fire inside your home. Have a plan. What are your safe routes? How, if you have a fire downstairs, where do you go? Can you get out the window? If you have a fire upstairs, maybe a room is blocked, something like that, and your fire extinguishers, know where they are. Check them once a year. When you check your batteries and your smoke detector, check your fire extinguisher levels and make sure they're okay. I've got 2 in my home. All right, a little bit of fun. This is cool. Color fireworks. So it's not just the temperature with this, it's the chemical that's in it. You got yellow sodium compounds, blue copper. That's pretty neat. And red strontium compounds. All right. And then finally, tip of the day, environmental, use less gas. Just make sure you're efficient. Turn off the fireplace when not in use, or at least in warm season, and vent when cooking with a gas stove. We mentioned that. All right, that's it for today, folks. Hope you learned a little something out there, and hope you have a good day, all right? And hope you learned a little bit something about fire.